that efficient tubing design recognizes the interrelated nature of each portion of the producing system: the reservoir and well bore, inflow performance; the tubing itself, vertical lift performance; the surface flow control equipment, choke performance; and the surface production equipment. If we test our newly drilled well and establish the relationship between flowing bottom hole pressure and flow rate, we may use this IPR curve as a basis for our design analysis. Using any of a number of vertical multiphase flow correlations, which relate pressure drop up the tubing to variables such as tubing size, water cut, gas-liquid ratio, and fluid properties, we can calculate various tubing performance curves. These curves allow us to graphically determine the flow rate for our system for any combination of parameters.
For example, the well represented by this IPR curve was tested at a rate of 1,700 barrels per day, with a flowing bottom hole pressure of 925 psia through 2 3/8-inch tubing. Using multi-phase flow correlations, the tubing performance curves for 3.5-inch, 4.5-inch, and dual 2 3/8-inch tubing strings may be calculated and plotted. We see that completing the well with 3.5-inch tubing will allow us to produce 2,500 barrels per day, assuming a straight line PI. 4 1/2-inch tubing allows a rate of 3,150 barrels per day.
Of course, the tubing size we may choose for our completion will be constrained by the size of the production casing. But simply choosing the largest possible tubing in order to maximize the initial rate is not a prudent design. For any tubing size, there is a minimum flow rate that is required for continuous removal of liquids. Below this rate, the well will be unstable as slippage of the gas phase through the liquid results in liquid holdup. The larger the tubing diameter we choose, the higher will be the rate at which instability occurs. So by choosing a large diameter tubing string, we may be sacrificing long-term producibility for short-term productivity.
Also remember that our IPR curve is valid for the current reservoir pressure only, and the tubing performance curve is valid only for the current water cut and gas-liquid ratio. Both pressure and flowing characteristics may change radically as the well is produced. Our analysis must consider the expected performance of the well over its entire life.